Hello students, today we will discuss the chemical properties of the alcohols, right? First type of reaction is the cleavage of the oxygen hydrogen bond, right? And first reactions of alcohol with the acid chloride, right? First you write down the reaction of alcohol. This is alcohol reacted with the acid chloride. Reacted with the acid chloride, right? This is the acid chloride, right? This one react, HCl is removed and R dash COOR, right? R dash C double bond OR, ester has been formed. Ester has been formed. Suppose you take CH3COCl, that is acetyl chloride, right? Acid means there are two carbons. In acid chloride we put the I chloride behind it, and next you take this one, suppose HCl is removed and you get CH3CO. Any type of ester you can prepare here. Its name is methyl. This is methyl, that is substituent. The oxygen के साथ जो मिथाइल ग्रुप अटैच्ड है उसको सबसे पहले लिखना है. देन नंबर ऑफ कार्बन एटम्स 2. फॉर 2 कार्बन वी यूज द एसिड, राइट? एसिड. एंड फॉर एस्टर वी राइट द suffix ate, acetate, right? Next mechanism. This RCOCl, right? And there are alcohol molecule having lone pair of electrons that attack to carbonyl carbon, that will act as a nucleophile, right? And automatically pi electron shifted above. Carbon will not form more than 4 bond. R, C, O negative, then Cl, then O, R dash and H. Oxygen uses its lone pair of electrons for formation of bond with this. Oxygen has formed 3 bonds, so has positive charge over there, right? In next step, 2 electronegative atom at same carbon atom unstable, so electrons come back and Cl is removed, and you get R, C, oxygen, and then oxygen, R dash and H. There is positive charge, H is removed as a H positive and electron shifted here. माइनस क्या होगा, यहाँ पे माइनस Cl नेगेटिव और यहाँ पे माइनस H पॉजिटिव, RCOO dash, ester is formed, and one H positive and one Cl is removed in the form of the HCl, right? That is the reaction of alcohol with the acid chloride. Next, third type of reaction. Reaction of alcohol with acid anhydride. Acid anhydride. Same type of mechanism. Here you take ester, R, C, O, C double bond O, R. That is acid anhydride. This is a acid anhydride. Why we call it acid anhydride? Because when we take carboxylic acid, ठीक है, acid you take it, and in presence of dehydrating reagent P2O5, right? This dehydration is takes place. Dehydration takes place, and anhydride has been without water. The water is removed, and that's why we call it, from the acid there is acid anhydride has been formed, and that's why we call it acid anhydride, right? In the chain or further second, you take R dash, right? Again this type of reaction takes place, right? Carboxylic acid is removed and ester has been formed plus RCOOH. RCO, carboxylic acid plus ester has been formed, right? And that is a carboxylic acid. Now we write down the mechanism. Okay, mechanism. Here, in case of mechanism, same mechanism just like that of the acid chloride, right? First you take the acid anhydride, or even you can change it, you write it here CH3, okay? This one, this is a, for two, there are two carbons, so for two carbon we use the acid, right? Acid, and for carboxylic anhydride we write it acetic anhydride. We write the acetic anhydride. Here in acetic anhydride, that is react with the this one. Or here you can take even C2H5, right? Alcohol. See how it reacts, right? Now this one, during the mechanism, this alcohol has lone pair of electrons, that one act as a nucleophile, ठीक है? कहाँ पे अटैक करेगा? यहाँ पे lone pair of electrons है. That is electron withdrawing, that is electron deficient, so it has partial positive charge, right? And that nucleophile attack over the carbonyl carbon, right? CH3C. Carbon will not form more than 4 bonds, so pi electron shifted here. Oxygen, negative charge, right? Here oxygen, C double bond O and CH3, right? And alcohol molecules that attached with this. And oxygen uses its lone pair of electrons, so oxygen has positive charge. It formed 3 bonds, uses its electron pairs, and now electrons come back. 2 oxygen atom at same carbon atom unstable, and so this is removed. This is removed, and there is, now you see CH3C double bond oxygen, oxygen H and C2H5. Now H is removed and this electron shifted here, and you get CH3COO C2H5, right? Ester has been formed, and here plus minus क्या होगा यहाँ पे? Minus is minus O C double bond O, right? CH3, right? H which is removed from here, that attached with this, and carboxylic acid has been formed, and that is, its name is ethyl. This alkyl group which attached to oxygen is written first, right? Ethyl, then you write number of carbon 2, ethyl acetate, or plus the H which is removed in the form of the acetic acid, plus acetic acid has been formed. Okay. Third is the reaction with the carboxylic acids. Carboxylic acids, this is the structure for the carboxylic acids. Alcohols, they react with the carboxylic acids, right, in presence of the mineral acid, concentrated sulfuric acid, right, or in the presence of the HCl gas. When we heat it, then correspondingly OH is from here and H is from the alcohol that is removed and ester has been formed, plus water. And this is the ester, right? And that's why this section is called the esterification. What is esterification? Esterification, when carboxylic acid reacts with alcohol in presence of the concentrated sulfuric acid, then ester has been formed, and that is called the esterification. And this reaction is reversible, and this reaction is catalyzed by the acid, right? And correspondingly here, how you give the name to this esters. This alkyl group is written first, right? In the chain, there is, you check number of carbon atoms. If there is, suppose we write it to be I, single bond A, and we put the suffix OH, right? Alkyl, alkane, OH. That will be the name. Now we will discuss another example. Suppose CH3 CO C2H5. Its name is ethyl. Number of carbon atoms 2. So it single bond. So A and put the OH. Ethyl ethanoate. This is the IUPAC name, right? Similarly, you can give the name common name also. Common name, in common names, there is for one carbon you write the for 2 carbons acid, for 3 carbons propione, and 4 carbon butyl, right? It means its name will be common name ethyl, right? Number of carbon in the chain 2, common name acid for the 2 carbons, and the suffix we put 8. Here we put the suffix OH, and here suffix is a 8, ethyl acetate. That is the nomenclature for the esters. That should be clear, right? Now we discuss the mechanism of esterification. In case of this section is reversible, I have told already, and this reaction forward कैसे जाएगा? You have to remove one of the product, right? During the esterification, you remove water by the clean and strong separate, right? Water is heavier, that settle down, to remove it, and the ester has been left, right? one of the product you remove, the reaction will be go forward. Now we discuss the mechanism. In mechanism, there is, you start from the acid, right? Sulfuric acid is used as a catalyst, right? That catalyzes the reaction, and correspondingly there are lone pair of electrons on the oxygen atom, two lone pair of electrons oxygen atom. First protonation, प्रोटोनेशन किसकी होगी, इसकी होगी, ठीक है. और फर्स्ट कार्बोक्सिलिक एसिड इज प्रोटोनेटेड, प्रोटोनेशन. H positive ion, no charge, it means oxygen form 3 bonds, positive charge. Now this one undergo resonance, pi electron shifted here, and second resonating structure is this one. This is the second. Carbon has more positive charge, right? That acid that catalyzes it for attack of the weak nucleophile unit. Now second, there is first acid protonated, then alcohol molecule that is a nucleophile, right? That nucleophile back to the positively charged carbon atom. R, C, OH, OH, oxygen, R and H. Oxygen form 3 bond, so positive charge. And carbon कितने बॉन्ड बन गए, 4 बन गए, कोई चार्ज नहीं, इसलिए इसके इलेक्ट्रॉन यूज करके बॉन्ड बनाया. ऑक्सीजन के 3 बॉन्ड बन गए, इसके कोई पॉजिटिव चार्ज आ गया, इसने अपने इलेक्ट्रॉन यूज किए, राइट. इन नेक्स्ट स्टेप, नाउ देयर इज वन ऑफ द H रिमूव क्या करना है, वाटर रिमूव करना है, ठीक है. वाटर रिमूव करना है तो इसका मतलब यहाँ से एक H दैट हैज बीन ट्रांसफर्ड बिकॉज देयर इज लोन पेयर ऑफ इलेक्ट्रॉन ओवर, one of the OH that is shifted, and R, C, OH, if you R dash here, R dash and R dash, okay. Now oxygen form 4 bonds, so positive charge. Next, water is removed. R, C, OH and OR dash. There is positive charge minus water, right? In next step, H, which you have added during the initial, during the start of the reaction to protonate it, right? That H is R, C, double bond oxygen, OR dash, H2 has been formed, plus H2. That's why we got sulfuric acid is used as a catalyst. First we use it and then that is removed during the reaction, right? This is the mechanism for the esterification, right? Next, now we will discuss that during the reaction, how you can prove that from the acid OH group is removed and from the alcohol H is removed, right? It is proved the cleavage in acid, there is cleavage of the OH bond. OH bond is cleaved here. Where in case of alcohol, isotopic trace studies. We take one of the isotopically labeled. Suppose you take CH3, CO, O, C2H5. Sorry. Suppose you take C, O, H plus. Second, ethyl alcohol, right? To prove it, we take oxygen, isotope of the oxygen, that is OAE in ethyl alcohol, and then we perform the reaction. Perform the reaction, and we found that in ester there is isotopically labeled oxygen is present in the ester, which you have taken in ethyl alcohol, right? From this clear that there will be the cleavage will take place between oxygen hydrogen bond of ethyl alcohol and carbon oxygen bond of the carboxylic acids, right? Next we will discuss the relative reactivities of alcohol and carboxylic acids. In case of carboxylic acids, smaller the group of carboxylic acid or alkyl group, more easily it will react, and it means formic acid react more fast as compared to the acetic acid and as compared to the isobutyric acid. And here in case of alcohol also there is methyl alcohol that react more easy as compared to ethyl alcohol, and then isopropyl alcohol, and then tertiary butyl. And that is that depend order of reactivity that depends on the steric factor, right? That is all about the esterification.